All right, so this is, once again, this is the Code BMB team, and this is workshop 1. As I mentioned last time, there'll actually be 3 workshops in this series, and those are the formal workshops we're setting up. We haven't talked about this, but if, as you're going along, if you have questions or you'd like, if you'd like some help, I'm sure we could arrange, other members of the community could join you to help you with things. Let's say you decide you want to try something this fall, and you need to get a little courage, then reach out and let's talk about it. All right, here's our team again: Chris Burnson, myself, Mike Foster, and Wally Novak. And just to let you know what's happening, we'll have just going to start out here. I'm going to address a few common questions, then talk about the project possibilities, what we're going to be doing later. Then we're going to move on to linear regression. Wally's going to lead that. We'll take a break. And then Chris has got a session on using AI, using Gemini to modify code as you're working in Colab. And then we will have projects. There are 4 different options under projects. One is Colab and Python basics. And if you feel like you really want to go back and review some of the stuff from day 1 that didn't quite click and you don't feel like you're ready to jump into one of the other notebooks, that's great. Mike will be hosting that. And then we have 3 others, one on linear regression, one on nonlinear regression, one on BioPython sequence analysis. Chris and Wally and I will be hosting those and drifting around. We'll set up 4 breakout rooms at that point. And so you can just select the breakout room you want to go to. And then what we would like to do at the end of that time is to come back together, and Mike is going to host a time where people can talk about their experience, what they did, what happened, what worked, what didn't work. And then we'll close with our resources, our next steps. And I do want to mention that there will be an exit survey. A couple folks asked about certificates for this workshop. We will provide a certificate, and that the condition of getting that certificate is completing the workshop survey. Okay, before going too much further, I want to talk about mindset in this whole process. Now, I suspect many of you have heard of Carol Dweck's book on mindset and her work on growth and fixed mindsets. Just the 30-second summary is: a growth mindset is somebody who says, I can learn, and a fixed mindset is somebody who says, I know what I know, and I can't, I'm not ready to branch out into new areas. And so we encourage, as educators, I'm sure we all look for our students to have a growth mindset, and I'd encourage all of us to embrace that same mindset ourselves. Now, we're here to learn how to use coding and how to teach our students how to use coding. We're not here to become experts at coding. So the more you do it, the better you get at it. I mean, that's normal. That's the normal process. But our goal here isn't to make expert coders. Our goal here is to help us as a community learn how to use code that exists, learn how to develop code that will help other people, and to share that with each other. And I do want to emphasize that idea that we're members of a community. We're people that want to do this, and we see a need for coding and AI in biochemistry and molecular biology education. We ask questions. And the first question I always ask is, has someone already written some code that I can use or adapt? Is there something already out there? For example, I looked up Colab Michaelis-Menten today, did a Google search, and the first page was loaded with a bunch of different pages that people had set up. They all had different looks and feels, but it was the same stuff. Can Gemini or another AI tool help me with the code? That's a possibility. I'll talk about that later today. Actually, Chris is going to talk about that in great depth. Can I ask someone else in the PyBMB community? Is there someone out there? And we've got a Slack channel, one of the questions on our exit survey is, would you like to be invited to the Slack channel? I couldn't find a way to give a link that you could just automatically join. You have to be invited, so I'll have to put your emails in. Finally, can I find some answers on Stack Overflow, which is a wonderful resource with information on solving coding problems. Now, going on to some questions that came up. One of the questions was, is there a list of functions or pandas commands that we can use as a resource? Well, there's a lot of things out there. And so I just did a quick search for pandas cheat sheet. And this is a cheat sheet that was generated by somebody on LinkedIn named Naveen BG, and gives examples of some of the things you can do and groups them pardon me, groups them very nicely. Okay. And so that's a nice one. I also did some more looking. Now, there's a lot of cheat sheets out there that you can pay for, but I think, that's up to you. But this was another one. The people actually on the Pandas development group on GitHub has generated a cheat sheet with a couple of very nice pages that are a little easier, more graphical than the other one I showed you. So these resources are out there, and there are also people on YouTube. Some of them are very good, and we'll try to highlight those not only here but also in our Slack channel and in our LinkedIn group. So another question that came in: being in a state with lots of new data centers, there are a lot of conversations about environmental impact. What kind of conversations are you also having with your students about the environmental impact of doing this work in this way, especially when using Gemini for helping with codes, or using Colab instead of Excel, or when you process data sets using cloud computing? And the quick response was, we don't have a formal approach to this as a group. We haven't. This is an ethical issue that we can talk about as a community, and I think that's something that should be part of our discussion on Slack. And I think that there's cause for concern, and I've heard different people, different approaches on this. It does consume a lot of energy, and so that's something we need to wrestle with. I don't have a clean answer on that one. Another question was also, can you use Colab without giving it permission to all of your drive? You can select how it uses it, but I don't see an option to reduce what parts of drive it has access to. I don't know that you can restrict it to a certain folder in your drive. Okay. Now you can use Colab without connecting it to your drive, but if you do that, you'll need to download whatever you generate on Colab. You'll need to save that, download it to your computer as an IPYNB file in order to have it in the future. Any other comments from the other team members on those questions?
I'd like to say that Colabs, most of what we're doing is in CPU only mode. And so the energy use of a CPU versus a GPU at these data centers is a little bit lower. That doesn't mean that there's still not an environmental impact, but the amount of energy that you're going to use for that, most of what you'll be using it for, unless you're doing a big, massive data set that needs a GPU, or you're doing MD or running AlphaFold, the environmental impact will be lower. Not zero, but lower overall. Also, the collabs can be run on a local Python version. If you have it, you could convert it to a Jupyter notebook and run it locally. So we can probably pull together some instructions on how to take a Google Colab and run it in Jupyter for those who might be interested. It requires a few more steps, and that you have to run it on your own computer, but that would also lower the environmental impact for those who are concerned about that. In terms of using Colab without Drive or giving it permission for all of your Drive, I won't say that I've encouraged students to create dummy Gmail accounts, but that is one way to do it, is just have them create a Gmail account that has nothing else in it. And then they've got that doesn't have access to all their other files when you're using Collab.
Thanks, Chris. I see a question from Padmanabhan. You know what? Allow me there. Okay,
Oh,
go ahead.
so I have a very dumb, naive, generic question. This is regarding use of Colab. So I see like everybody or Colab, GitHub. So everybody puts in all these Python codes on GitHub or Colab. Can I use like say a VBA like a macro to be there, or it doesn't work that way? You understand my question? Or my question is kind of wrong?
Right. I can't answer that. Can others answer that question?
So we're going to talk about VBA, or talk about Visual Basic.
Yeah. Say I write a macro. Can I still have it on that, or it's not going to be recognizing that kind of a code?
Uh, and this is where, Wally, you also have experience with it. So Colab, as far as I know, only runs R, Python, and Jupyter. If you have
Okay.
an interpreter in there,
Uh-huh.
there probably is a Python interpreter for Visual Basic that
Okay.
would allow you to run it. But it would probably not be straightforward to do.
Okay, okay. Because haven't I have never deposited anything on GitHub, but I have a lot of macros and I keep thinking, how do I put that? Like, where do I put them? Will Colab be a useful repository for those kind of macros? And most of them are using Visual Basic because we use that for, you know, scanning through the data that is on Excel, uh,
Yep.
like a gene sequencing data that we have on Excel. We use that for I've written some macros for them. So that's why I asked that question. Anyway, thank you for
Okay.
your information.
You're welcome.
Yeah, I think that that's a one of the challenges of coding is the software is always getting newer. You're getting new languages appearing, new applications that may not work with the older code. And so this is where GitHub is useful. You can put those macros up there in GitHub and share them. And then longer term, you may have a student or something who would want to try to convert Visual Basic into Python. And that would be actually a fantastic project for them to learn and learn how to convert between languages.
Okay. Now, the project possibilities, we're going to have 4 different options this afternoon. So we'll have 4 breakout rooms. The first one is Colab and Python Basics. If you're brand new to this and you feel like things are just flying by a little too fast and you want to go back and get more comfortable with some of those things, you want to make sure you understand how a loop works or how logic works, then this is the right place to be. Mike will host that. And then we'll have a session on protein assays and linear regression, another session on enzyme kinetics and nonlinear regression, and another one on BioPython sequence analysis. And we'll start out with the hosts that are listed there. We'll see how things go and how the crowds are, and hopefully people will be talking with each other and working through things. And those of us who are the hosts will be mostly there to maybe answer questions from time to time, but for people to just wrestle their way through things. Okay. And so it'll be an experience of coding in community, and we'll see how that goes. And that pretty much wraps up what I want to say at this point. So I'm going to stop sharing my screen and move on to our next step, which is we're going to turn it over to Wally, and he's going to start talking about linear regression, and this will be in Colab notebook number 4.
Thanks, Paul.
You
I'm going
bet.
to go ahead and share my screen. I want to get us started and remember just to review some things from 2 days ago, which would be going to github.com, either /codebmb, which is where we've got all of our files, and we can find our repository. And we can always go here and click on this May26. The one that we're going to be using today is, or this morning, or not, it's not morning. The first one we're going to be using is this 004 linear regression template. And of course, we can click it and we can then click the Open in Colab button. But if you forked our stuff last night, I want to take a minute and show you if you forked this repository last time, this is what it might look like. So this is my forked version, and it says this branch is 12 commits behind CodeBMB May 26. So now I'm looking here in GitHub, and that means that we were busy over the last couple of days editing these files, and your files that you took are not updated. But this is one of the beautiful things about GitHub and forking that, because now all you have to do to get yours in line with the CodeBMB branch is to click on this sync fork button. So I'm going to do that now, and it's going to say, oh, this branch is out of date, which is mine. And I can keep it up to date by syncing the 12 commits, which are the snapshots that we've updated. So I'll just say update branch. And so now my branch is up to date, and now my version has all of those changes that you would want to have in order to make sure everything runs appropriately today. Okay, we're gonna try a button thing. Did that make sense to people? And if so, click like there's the little yes button under the reactions. We'll see if that flies. Or if no, or if the answer is no, click the no. I see some thumbs up. Okay. All right. And I see some yeses. All right. I'm going to run this back from the code BMB, but you're welcome if you've updated your fork to run it from there. I'm going to click Open in Colab, and we'll get started. This is an updated version that I'm calling a template. Because we have indicated in here areas that you can modify to make it your own, which we won't do right now, but it's one of the possibilities later on. And here's kind of a list of all the things that you could end up modifying. And our input data set, which is a standard curve. And we always start with how to run this notebook, just telling students they need to just click the play button and read all of the instructions. This is like a big one. They don't really necessarily always read it. And to ensure that every cell does finish running before the next one. There is a note here that says if you do want to update this template or your template and save it for use for students, you do want to make sure that you clear all the outputs so that they don't have anything pre-filled in. And it's a good idea just to restart that session before saving it back to GitHub. So that's just a little bit of a reminder if you want to make this for your students. You don't want it to be all pre-computed where they can see everything. All right, so we'll get started with our first block, which is just to set up our environment. And we're gonna okay, yeah, you can't see this, I think, but it's the warning that this notebook was not authored by Google. So we'll say run anyway. And it's got to connect to my connect to the server, which it did, and it has imported all of the libraries successfully. Then we use this theory block. So sometimes it takes a little while, depending on what libraries or software you're installing. The theory block gives students something to read while they're waiting for that to happen, but it's also a place for you to share the detailed information. So here we talk about the Bradford assay, linear regression, what an R-squared value can mean, accounting for sample dilutions, which is an important aspect of protein concentration assays, and how they might solve for that. Of course, all that's editable. Remember, if you wanted to edit yours, you can just double click in here and you can edit all of this. So going on to data acquisition, defining our assay parameters. Of course, this can all be modified. If you're using a BCA assay, you're going to want to modify the wavelength that your data is collected at. You might modify the concentration units if you did things in micrograms per mil, and of course, what type of assay. So there we set a lot of different parameters. And now we've got some different options for collecting data. And of course, you can enter and delete these. You can add your own data here. You can upload your own CSV file, or we can retrieve it from GitHub. I want to see if I've got this. So this downloaded it successfully. And if I click on my folder here, it's going to take a minute. There we go. I can look in, we made this data folder, and now I've got a file called standard. It's calling it standard curve here. All right, so it retrieved it as this, and it's calling this data URL now data/standard curve. So here we've got it, and we read it into our pandas. So we used pandas 2 days ago, and we used this df data frame.head to look at the top 5 rows. Okay, I'm not going to run B or C, but this gives some instructions on how you can do that. And it also gives some instructions on how to upload files, which is you can drag files right into this data folder if you would like to use your own CSV file. So I'm going to just close this to hide it. We do want to verify that our data was loaded correctly. And it's telling us that we've got numbers that are floats, which are these decimal numbers. So that's all great and it looks right. We are going to just run some cleaning. What this cleaning does, this drop NA, it will delete rows that have missing data. There are times you want to do this and there are times you don't want to do this. So note that if you did not want to remove or drop rows that have missing data, you can comment out this line of code and remove the comment from that, right? And so then this would just copy it without removing those lines. So there's a couple options here. I'm going to go back and we'll run this one. But recall any line that's got the hashtag in front of it is a comment and won't be run. But we don't have any missing data, so it's going to it should look exactly the same. But what we've done is we did copy this into a new data frame that we can work with without disrupting this original data frame at all. It's called clean data under a data frame. All right, let's start doing some of that cool stuff and revisiting things that we had done with pandas, but we're going to do it a little differently. We are going to calculate some mean values and standard deviation. We'll end up doing a couple plots, some with error bars and some without. And then we'll, of course, calculate unknown sample concentrations. So calculating the average and standard deviation. So we did some work on, using mean or standard deviation on pandas on Tuesday, but we were calculating that in a column. The way that our data is set up, if I'll just go back here, right, is these replicates are now all in a row. They're not in a column, right? It wouldn't make sense to determine the mean of the column replicate 1 because these are all different concentrations. So in order to calculate across the row, we're going to change the axis. And so that's what this axis 1 means. So we've defined the replicate columns, okay? And which we defined before, which I'm going to just kind of shoot back here. Replicate columns are rep 1, rep 2, and rep 3. And it's going to calculate the average across that. And so it made a new column, right, that contains that average. And then it made another new column called standard deviation, which calculates the standard deviation across those rows as well. What we had defined as replicate columns. So I just want to make sure that people understand what that axis is 0 by default. So if you can give it a thumbs up, or if you're struggling to understand that, if I can clarify things, giving you the stop or the thumbs down. Okay, I see a lot of thumbs up, which is great. So I'll go ahead and move forward then. And we'll look at some work that we can do. So now we want to do some learning and typing our own code. Now, I want to say that in the way this exercise is drawn is that the answer is here, but it's hidden. All right. So we do have an answer, but we have hidden it. But if you wanted, access to that, we have, students can access it, but it's one of those things that we could try. So the first thing here is print the average absorbance at the highest concentration. And we have the clue up here. First, we do want to print something, and it says that the highest concentration can be accessed using this iloc or integer location command. And -1 is basically, so if I start from 0 and went to 100, -1 is like 100. It's the end. It's the highest value in that set. So -1 is going to return that from the highest end. And so let's go ahead and start typing some code in, and it might fill it in because I think my AI tool is on. So print. So I'm going to do it open parentheses. And then I want to start by printing clean data frame. And I hit tab because it was starting to fill it in. I'm going to my open bracket. And now I can actually like choose some things here, and I'm actually interested in average. So I can, or I can type this out. All right, and then .iloc, open bracket, -1. And so now this is it should print whatever value is there. So I just want to see if this runs without doing anything else. I can run it. Okay, and it did print this highest concentration value. I can't see this. I'm going to change this to see if I've got that. Oh, there it is. So it printed this value. I just changed the head, right? I can tell it how many lines to return. I knew there were at least 6, so I just did 7. So it was able to access this value. We can mess around with that really fast. If I did -2, that's going to again count this way. It should be 0.485, which it is. All right, so that's a way that we can access, we'll just go put that back to access the highest concentration. Now it's asking us to add a new column called CV%, this coefficient of variation, and it tells us how to calculate it. So, and we've got this kind of commented out right here because this is not code, but we can access things. So, well, here's where AI is interpreting this for me. And it's correct, I think. So we'll double check it. It's starting with clean data frame, and this is a new column because it doesn't exist. And what that column is going to be equal to is, and open parentheses, the data that's called standard deviation, so that should be right here, divided by the data that's called average times 100. I think that should work. So let's display that. And it does return values. For 0, it's returning infinity. So this is kind of that power of having the AI tool turned on by default. If you forgot where that is, it's oh gosh, is it under Tools, Settings, and under AI Assistance? So leaving that on is sometimes helpful. Like I said, just typed all that out for us. It's intuitive in a lot of ways because it's reading all the code, but you can turn it off as well. And if we open this to click to see the answer, we can see that's exactly what we wanted to do. All right, let's look at plotting. And we also did some plotting. We can break this down a little bit. It's going to, this is a large plot, 8 by 6. It's going to plot the concentration and the average with circles, and it's going to give a label called average absorbance. And then it's going to print some labels for us. It's also going to make a grid and a legend, and then this actually tells us to show the graph. So this is all setting it up, and then this is what says go and write it. So let's run that. Okay, we can see we've got our absorbance here on the y-axis, our concentration on the x. So I'll just scroll a little bit back up. So here's our concentration column and average. All right, so we've got our average absorbances, and they're plotted. It looks like a very straight line. We can, you can again mess with things in here. Like if you're like, I need this to be smaller, let's just try and change it to 4 by 3, edit our code and run that. And now we have a tiny version of our graph. So it all fits on there nicely. All right, let's add some error bars, which is a little bit of a step up. And we can do that here. There is documentation for how to add that. And one of the ways that we can access documentation is to say help and then what we want to get help for. And so if I run this, it gives me a lot of information. So it tells me what the parameters that are that it takes in the format, and it can be a little bit dense, but it does give you some information. I'm going to hide this here. But there are a lot of optional parameters, and we want it to do Y error, right? So that's our standard deviation. And the format, again, is the circles. And this is just the small horizontal caps. Okay. So we're going to plot 2 plots, and that's what this is doing. It's telling us that we're going to have subplots, all right, 1 and 2. The overall figure size is 13 wide by 5 tall. And here's the first subplot, all right? So it's why we've got axes 0 and axes 1. So Python starts counting from 0. So this is the first one. And it's setting up all those same things that we saw before. Setting our X labels and Y labels. And so that's very similar to this code. I'm going to scroll up, so don't get dizzy. Just want to scroll up so you can see that that code looks a lot like this, all right? Except for we had to put this axis 0 in front of everything because we were doing 2 plots here. The second one is very similar, except for we've got this Y error, all right, which is going to also plot our standard deviation. And now we've changed our label, average plus or minus standard deviation. So let's see what that looks like when we run this. So we've got without error bars and with error bars. And so now you can see what those error bars look like. Okay, and if we adjusted any of those values were different, they're pulled right from the calculation from our data frame. All right, so we did that calculation. We calculated that column, and that's where they're pulled from. All right, that's standard clean data frame standard deviation. So this is just a nice comparison to see without and with. Okay, and of course it explains to students that small tight error bars are better. All right, let's go ahead and just rerun this. This is just generating a nice final error plot for us. Just a single plot with error bars. Okay. All right, were there questions about plotting, or are we all tracking?
Wally, we're keeping up with the questions in the Q&A window. Please feel free to use that.
Okay. All right, so we will drive on. I saw a lot of good thumbs up there. So now let's do this line fit. All right, so this is the most complicated thing. This is part of SciPy. So here's what I want to do. I want to show you a couple of ways that we can access this. We can do this help line regress, stats.line regress here. So what is this? Where's the stats? Don't do this. I'm going to scroll all the way up to the top here, though. I said don't do it. You can just watch me do it. From SciPy import stats. So that's where this is coming from, is that it's part of this SciPy library. Okay, so now I'm going to jump down and I just imported all the stats from it. And that's then things that we can use out of that library. Okay, so stats.line regress, if I click run, it's going to give me all the help. Or I can show you that, like, if you go, all of these libraries have documentation. And I'm going to make sure this opens in a new window. And it says it's sending me someplace else, so that's fine. Here's line regress, right? And it tells us a whole lot of stuff. Line regress, X, Y. There's some alternatives on how it's going to do that, what axis it needs to do. So this can be, again, it's quite complicated, but I want to show you what it returns. It's going to tell us the slope of this line, the intercept, R value, the P value, the standard error, and it can also tell us the standard error in the intercept. So I'm going to minimize that, and I'll show you where we can see that here also in this help. This is maybe a little bit easier to read once we get down to it. So this looks, very much the same, right? But I'm going to go down just a little more right here. Okay. It's telling us that we've got a couple ways that we can do this. We can say result equals line regress X and Y values, or we can actually unpack all of these variables independently first by saying we know it's going to return the slope, the intercept, the R value, the P value, and the standard error. And there's a couple ways that I will show you that we can look at those variables and refer to those. So I covered this about what it's returning. And so let's explore that, okay? So I've got concentrations, right, is my concentration columns. That's going to be my X values, right? And then this absorbance is going to be my Y values. And so we've got to put it in result equals the stats.line regress. Here's my X values. Here's my Y values. And now to access all of those variables, the slope, the intercept, the R value, I apologize for all those little pop-ups. It just does that. They're all stored in result. So if I want to print them, I can say print result.slope, print result.intercept, et cetera, et cetera, et cetera. So let's run that. So here it is. It's returned the slope, the intercept, and all those things, and they're stored in these values result dot, because I just read them all into the single result, and we can return each of those. And now these names are fixed. They are determined by that dot slope is fixed by that line regress package. So if I kind of went back up here and showed this hidden output, it tells us that it returns slope, intercept, R value, P value, standard error. And that's how I had to refer to them. Let me show you one more way, which is, oh, I thought I did both ways. Oh yeah, this is the other way, but we're just doing it in another step. We're also going to end up unpacking this in calculator unsquared. So instead of reading it into a single variable called results, notice I'm just pre-listing them in the order they're going to be returned: slope, intercept, R value. This is a different name. This is R value, R underscore, P underscore, and standard underscore error. So I could name these whatever I wanted. I could name this, puppy dog, goldfish. But, obviously we want to name them something that makes sense. But here all of these stats will be put in order into these. All right. But again, I'm giving it my X and Y values. Additionally, I'm going to take this R squared value, R value, and square it. And that's how we square something in Python. It's asterisk, asterisk 2 to generate an R squared value, because it's returning R, not R squared. And so now note, when I want to print these things, right, I just call them by the names that I assign them up here. Slope, intercept, puppy dog, goldfish, or whatever. I'm just returning those. And then what we've done down here is we're going to evaluate our fit. So if that R squared value is greater than 0.99, we're going to say you did excellent. And if it's greater than 0.95, it's acceptable. And otherwise, we need to check something. So we'll run that. And we can see that we return the slope, all these same values, and our fit is excellent because our R squared value is 0.999. So I know that's like a small point. So if you're a little bit confused on how that result can be returned, I could just have it return slope. Could be the only thing I'm interested in. But it's going to return them in the order that is listed in the documentation. Okay, so I think this is almost the last thing, which is let's plot this best fit line now. Okay, so this is using NumPy. This NP is NumPy, which I imported again at the very beginning. You can see where that was imported. Um, and it's going to plot this, and we'll also get the equation of the line here, because we've got the sloped and we've got the intercept. We determined those already using the SciPy up here, right? We have a slope, we've got an intercept. We can plot a line. So we'll run this, and we've run this on top of our plot that already is going to plot, right? The data with error bars. And so we have this beautiful plot that we're given the equation of the line. It's got our nice R square value that's rounded to 1. So anyway, if my student data looked this great, I'd be very happy. Sometimes it does, but usually not. All right. So this is one of those things here where we can ask, you to do some programming or coding. So we wanted to use F strings in order to display those. So for example, we're given a hint on the first one. We want to display the slope, intercept, R squared P, and standard error. And we have to use the, F at the beginning, a quote, and then what we're going to put in there is something like, I'm just going to copy it and paste it in there, slope for dot for F, okay? And if I run this, it'll run. I've got my slope. If I put dot 3F, you'll see that I'm going to lose precision here. All right, that's all we're controlling with that dot. Okay, so I've got 4 decimal places. So intercept would be the kind of the same way. So I'm going to copy it and paste it, but I'm going to change slope to intercept. Okay, I'm going to paste that again and change this to R squared, which we calculated before. Change this to P underscore value, P underscore value. And this one is supposed to be standard error. So I'll show you 2 things here, standard underscore error. So we've got that. Now, remember, this is after I unpacked them and read them in. I also returned a result, right? Let me go back up and I'll just show you. I did return a result up here, result dot slope and result dot standard error that I can actually result dot standard. And this is not what it's, there's no underscore in there. So this should work also. It does. But if I try to do this result dot standard error, oh, it says this result dot standard error is not a part of line regress result. So we have to use the default naming as part of the linear regression library. So that's a couple of ways that we could have done that. I'm not going to do the if else statement, but you can see it down here. It's again, what I would have done is just kind of copied it from what we did up here. We can copy that. I guess I will do it. Paste it. And excellent. All right. This is again an area that can be modified where we're going to start getting into what samples we've got. This is how I often label them: cell-free extract, flow through, elution 1, elution 2. So these are some descriptions. These are the absorbances of my samples, and these are the dilution factors that I would have made. And so I'm going to run this cell. I know that we've got just a few minutes here, and it's made this little table for us to show us, and a student should be able to recognize that this looks correct. We talked about dictionaries, I think, in Notebook 2, where we can assign things using basically dictionaries here. So I can run this and we can do the same. We can do the same kind of thing. A dictionary is where we are assigning a valuable, like it's like when you have a dictionary, you have a dictionary and you have a definition. So you have what that is and then what it's defined as. And so that's how we can use dictionaries. So we have here sample names and dilution factors. We can also put things into a data frame, just like with pandas, and we've got the same data. We're just putting it into a data frame. So we have multiple ways. I would not use all of these with students. I would pick whichever one I was most comfortable students using. It might be the pandas data frame. It might be a dictionary, or you could just make them in lists here as well. Okay. If you've got a list, you can add your own unknown samples. I'm going to skip that for right now. Or is it the last thing we've got? Oh, this is the last thing we've got. So we can add a wash sample. So we're going to add it to, it says what to do here. Add W1 to sample names, wash fractions to sample descriptions. And so if I go up here, we can add, I can go all the way back up, W1 for a wash, and I can copy this line, paste it when I get rid of that tab, and just call it wash 1. And it does it I think it said what I would need to set it to 0.357, and it's got a dilution factor of 3. So I'm just editing what we've got here, our data, and my dilution factor is 3. Hey, so we were able to add that. I can rerun these, and they're going to pull in that wash and calculate the true concentration, or I can do it in a data frame. Same way. Okay. I have hit the end of my time, but I hope you can see that in 30 minutes we were able to run through this, and I hope you can see that there's a lot that you can edit here. I think relatively cleanly as a professor, so that you can have this for your students to run and become familiar with and do a simple task that we do every day.
Wally, before you stop and
Yeah.
keep your screen up. I want to talk a little bit more about your results, the
Yes.
data type that came from that function. If you could scroll up to that.
From which function here?
When you did the lin regress function, it gave you the 5
Oh,
outputs.
sorry.
And you do
Yes.
it as results. And when you did that, I thought, well, maybe results is a list. Well, in fact, it's not a list.
It's not.
I think you asked it to define the data type in that cell. I don't remember where that cell is.
Sorry, I gotta remember where I am here. Oh, I'm higher. It's an object.
Right. So if you look at the bottom of the screen he has right there, roll it up just a little bit. It says type of result, class scipy.stats.stats_py.lin regress result. So it's a very specific data structure that exists, and you can access the attribute to that data structure by using results.slope or or result.intercept. So this is a very common thing that you encounter in Python. I do a lot of work with RDKit, and it's the same. RDKit generates its own kind of very specific molecule object. You can access that molecule object, the attributes, with the right term. So I just wanted to go back and review that, because this is a very common thing that happens in Python. And when you're working with data, you have simple stuff like a simple value, a float, an integer, a list, but then there's a lot of other more complex data types that are actually very powerful.
Right. And then just to follow up with that is that you can unpack that object in this way by assigning your own variables, and it'll unpack into those variables without returning that object. So, and then you don't have that object. You've already unpacked them into individual variables. So there are two ways to do that.
Yeah. So I just wanted to reinforce that because when I saw that first, it confused me enormously. So,
Yeah. Yeah.
all right. So what we're going to do now is we have a break, and I think we'll come back at 5 after the hour. And at that point, Chris will take us through an exercise with AI.
These are things that other people want you to use. And so you can create these collabs and you can build it around their code. So all of the text here is what I added, and then I went through and adapted their code to make sure that it would work. In this case, I'm doing sequence alignment. And so it pulls homologs from BLAST and then starts looking at redundancy. And then you can visualize the clustering and see how similar your proteins are to each other. And then it does the sequence alignment and puts it in pretty colors, which makes it nice for students, and shows gaps. And then you can download all of this code and it creates an alignment you can put into Chimera and then take your model from AlphaFold and add your alignment. And then you can color your structure by conservation, just like conserve and other types of things too. But the students had to work through it. So when you're thinking about getting started, think about the things that you do and you know as a biochemist or that you want to teach and look for code that gets you there. And then if they've got code available, start copying that. If it's a little inaccessible, then that's where AI or the community may come in to help you. So I've got posted on the code BNB repository, which for some reason I neglected to have up here amongst all the other tabs I do have up, a notebook. It's number 7 and says AI Gemini coding. Go ahead and pull that one up. And it is functionally a copy of the 004 notebook that Wally just did. But I've taken and skipped over a lot of the steps, and we're going to go right to the end and build on that end part to do some additional tasks. And we're going to use Gemini within Colab as an example for how, but then we'll build on that to understand more about the advantages and disadvantages and think about what might be the best way to go about some of this. So I'll give everyone a moment to pull that up. And don't forget to make a copy, and also don't forget to terminate any previous sessions that you might have. That way you don't get caught in the Colab trap of having too many sessions running simultaneously. All right, so Colab, because it is a product of Google, uses Gemini as its particular LLM that it's using within here. And remember that Gemini and Claude and ChatGPT and Grok and all of these things that we call AAI or AI are large language models. They are effectively predicative autocorrect. And when you are putting a question together, what this model is trying to do is predict what the answer would be if you kept writing and going forward. And so all of the advantages and disadvantages of ChatGPT and LLMs that plague our students and challenge us as we are trying to get students to learn material, all those biases and the underlying challenges with data are still here when we're trying to write code as well. These models are only as good as the coding data that's publicly available. And so they were trained on public information in GitHub and Stack Overflow and a lot of these existing resources that are publicly out there. So about a package like information out there, you're more likely to get a good answer. However, if you are looking for a more niche package, you may have some challenges and may be not as successful in writing code or using the LLM to help you write that code because it doesn't have as much information to predict the text about. So be warned that there are some biases in how well these can answer. Now, within Colab, there are a couple different ways you can get to the AI. There's the button down here at the bottom. And then in code blocks, if you have one pulled up, in the top right of the code block, as you have it highlighted, there's the sparkle pen that you can use to bring this up if you want to change the code. For right now, we're just going to run the setups. Now, what this is going to create the data that Wally already assembled in the 004 notebook. And then it should be ready for us to then start doing some challenges and thinking about how we can make changes to this. And we'll work through one or two of these together, and then I'll let you play for a little bit of time, and we'll see what the options are. So we've got it loaded. We've got the slope and intercept in R-squared. They look very similar to what we saw in the fourth notebook. So now we will move forward. All right. When we're thinking about using LLMs and AI and all this for our coding, remember that you have to provide context. And so Gemini within Colab knows what's in the notebook, and it knows the information from outside that can help you. And so it can help you with things like changing parameter names and fixing syntax issues or adding columns. But it can't really answer a question about whether an R-squared is good, or whether your concentrations make sense, or whether your experiment actually makes sense. So realize that you're going to use the AI to work on your code, but it can't give you qualitative judgment that you have to use as a biochemist for this. And when you're thinking about writing code for Gemini, or if you want to use one of the other LLMs, you need to be able to say, I want my code to do this, but I don't know the Python syntax for that specific task. Meaning, I know what I want it to do. I know what I think I want it to produce, but I don't know the right word to do this thing. And that's where the LLMs can be helpful, is they can try to help you find that word or that function or that command to do so. But it's going to be less useful if you don't know how to frame that question. And that is where it can be very challenging. And there's that gap between early coders and people who know that basic syntax and can say words like tuple or list and confidently know what that is. And so this is where the LLM can be helpful, but you may want to do some Googling a little bit beforehand to try to get the vocabulary before you jump in, or use these tutorials to see what's going on and then work from a tutorial or existing code to go forward from there. What makes a good coding prompt? It's the same type of thing. What makes a good prompt if you use LLMs for other parts of your life? You want to have context. So what are you already using? Think about the libraries. Are you using pandas, matplotlib, scipy? Are you using RDKit? Put in variable names. Give it the information that will be helpful for it to answer the question. Tell it exactly what you want to change or add. You might even provide the code snippet and put in a comment next to that code snippet that says, I want to change this line. And so you provide code above your what you want to change a little bit below, and that'll help the LLM understand where that code is within your code. And then you can ask it to give you the code back. You can have it give you a full tutorial on what it does and what's going on, or give it a brief version. Give me the summary, the bullet points for how to do this. So you wouldn't necessarily say, how do I change my matplotlib plot? But you might say, I have a plot with these commands. The best fit line is currently red. I want to change it to green. Show me how to change that. And then if you just want the code, you can say no explanation. Or if you're learning, or if you're doing it with students, you might want to have it give you a little bit of explanation or a lot of explanation, or even tell me what website should I go to? Where is the manual for this particular command that could help you get to that particular spot? Just like Wally showed you in Notebook 4, where you can ask help and get this long page of information. That may be hard to find from a Google search, but maybe the LLM can help you find that page and then work your way within that particular help page and use the explanation that it gives as a way to go back and forth between what the people who are doing the production want to do and what you want to do in terms of the code itself. All right. So let's play with this a little bit. And let's run the baseline plot. Is it going to fail? Oh, wavelength is not defined, but we got what we wanted. Let me go back here. Let's make sure that it is defined. Did I delete it accidentally up here somewhere? I did. All right, so we're going to put wavelength in because otherwise it'll fail a little bit. There we go.
Chris, it's also going to want assay name.
Oh, thank you. Assay name. Is it one? Yep, there we go. See, this is where the AI helps. It auto-corrected for me. Fantastic. All right, so let's make our baseline plot. It works this time, and it looks exactly like Wally had it. And below, I've got you 3 tasks that I want you to start trying, and you can try using Gemini to do. And then I've got 2 challenges, which are a little more complicated, but they could help you move towards thinking about what you can actually do. So we'll go through the first 1 or 2 together, and then I'll let you all play on your own and ask questions for a little bit. So in task 1, I want you to change the marker style. Right now, the markers are circles, but maybe I want a triangle, or I want a cross or something like that. So let's try to use the AI to solve that question. So I'll open up Gemini, and it's asking, hey, what do you want to do? So I can go in here and say I'm in this code block. So I'm going to select the code block that I want. And I'm going to say, I want to change the marker shape in this plot to let's do a plus. Let's see if we can do that. And the marker is within. Okay, so I'll hit enter and it's going to work, and it's going to just kind of click along on its own. And it goes in and it shows me within the code using red and green what it was, and that's in the red, and what it wants to change it to, and that's in the green. And I have a couple options. I can accept it, which means it changes the code. I can accept and run, which means it changes the code and it runs the code to produce the result. Or I can cancel and say, oh, I need to change my prompt and I want to do something different. I'm going to accept and run in this case and hope that I was right. And it worked. And we got this little cross thing. It doesn't look much better, but it did the change that I wanted. And then it follows up and says, I changed it and it looks like it successfully worked. If it had failed, say that you changed something and broke the code, Gemini frequently will go back and try to figure out what went wrong, and it'll try to update it. And so you can go back and forth between, try this. Oh, that didn't work. Try it again. And it will integrate really well with making those changes. You can also see that, like most LLMs, it's very enthusiastic about doing the next tasks for you, and it can help you along that way. I want to point out, though, that Gemini within Colab can sometimes struggle. But for these types of tasks where you're doing really sort of fundamental changes to a plot that's already there, pretty well established, it usually works. So why don't we take maybe 5 or so minutes, try some of the other tasks. We probably won't get through them all, but at least we can start and see how it worked. If you have Claude or ChatGPT, or want to use Gemini separate from this, you can do that. You probably want to copy the code in to the prompt when you ask the question, and you might get a response that way. So play with it a couple different ways, and we'll get some feedback from you all on what you think is the best or what you found was interesting. All right, let's come back together, and we'll do just a little discussion maybe in the chat about, what was the power of the AI for you as you were using the LLMs? Did it give right answers? Did it give wrong answers? How did it work for you all? What should we be thinking about? So go ahead and if you want to put those in the chat, we can do that. And of course, we can have a broader discussion a little bit later on, but just initial thoughts. Yeah, that last task is a little tricky, trying to get that second plot in there. It makes a residual plot. This is where you start to see some challenges. Yeah, great. So it worked well for others. Good. Yeah, for depending on how you ask the question and how you set things up, there can be some challenges to this. As an example, I was working with my lab students yesterday to convert absorbances using Beer's law to molarities and then mgs per mil. And I told them to use Colab rather than Excel. And they went through and did the Python. They used the AI to predict it. And they had three different methods for taking a CSV file and taking the numbers in there and converting it into concentrations. So be careful that different ways will give you, or different LLMs or even different days, different people will give you different answers. And so there's a bit of randomness into this that you may need to be thinking about if you're doing this with students, and that they may come to you with code you haven't seen before because Gemini gave them a different answer potentially. So, and just to show you one more thing about how both cool and scary this can be, I'm gonna share this. I told Claude at 11:24 that I wanted to create a Google Colab for me using RDKit, and I gave it some code that I wanted to do, but then I told it I also wanted to have it do 3D visualization. And 2 minutes later, I had an entire Google Colab that has it go step by step. And I haven't opened it up to see if it works or anything, but I have a Colab and it gives me gallery views and all types of things I didn't ask for and I didn't necessarily want it to code, but it gave me all of this. So those of you who are playing with this, these LLMs can be enormously powerful, but they can also challenge you in that I wanted simple code and I wanted a 3D visualization, and it gave me something that was a little bit more than I wanted. And we all need to be careful about that when we're thinking about um, coding for ourselves, but also for our students. So I think that I've hit my time, Paul, and I think we're ready to move on to the next section, right?
Actually, the way we had it set up, Chris, is I believe we had this session slotted until 2:50.
Oh, wow.
But uh, I I mean I think you've pretty much touched on all the things you wanted to there.
Yeah.
And what this does is this actually gives us something closer to an hour that people can actually work on these different projects. And something I wanted to mention to the co-hosts, I think as a co-host you can record what's happening in your room. Now, I apologize. I actually missed the first 2 minutes of your session here, Chris, but I got it before you went to Notebook 7, so at least I got that much. But I missed
Oh
the
man,
earlier
you caught my
part.
mistake then.
Right. And anyway, so what I'm going to do is I'm going to pause the recording here. I'm going to set up breakout rooms. Let's take a 5 minute break. Give me about 5 minutes to get that set up. I'm going to try to not just make the breakout rooms, but label them so you know which one is which. And then we'll go from there. So 5 minute break at 2:35. We'll go to the breakout rooms, and you'll be able to pick whichever one. And if I can't get the labeling right, one is going to be Colab and Python basics. Two is going to be linear regression with protein assay. Three is going to be nonlinear regression with enzyme kinetics. Four is going to be sequence analysis with BioPython. Okay, I'm going to try to get that in the titles. We have a few people still coming in. We've got, I think, 6 or 8 folks that are still need to join. All right, I just closed the breakout rooms, and when I hit that button, there's a 60-second warning, so that would have come up. So okay, I think we're all back. And so I'm going to turn it over to you, Mike, to host a discussion of what happened, what people saw in their breakout rooms.
Very good. So, no really well-structured discussion planned here, just hoping people are willing to, talk a little bit about what they were trying to do, maybe some things that were interesting that they think could be useful moving forward, or, points of difficulty. If you're interested or willing to talk about what you're working on, you can throw your hand up or raise your hand, I think is an option in the reactions. I was initially in the basics of coding room. Nobody joined me there, which, is a good thing. It suggests that, we understood most of the material from our Tuesday session, which is reassuring. Hopefully that pattern continued today.
I think with this AI tool right next to your window where you need to have the code, I think it really helps, especially with Chrome where you can, sorry, uh, you can really type in what you want and it gives you, and then you say, hey, put that in, and it does it. So
Yeah, the
that
integration is
definitely.
very easy to use. And you can even just, highlight a block of code and you can, click the AI magic wand, if you will, and it'll provide you some sort of interpretation.
Also, if you've written some code and it works, but it's really kind of ugly, you hit the magic wand and it'll make it neat.
If my code works, I think it's beautiful. Pretty low bar to pass.
In the breakout room on the nonlinear regression, we went through the exercise. It was very nice, but there was an interesting discussion about why use this instead of just using Excel or GraphPad that I've been using all along.
Mm.
And I thought that was a good discussion, and I'd invite people who are in the room to share about that, and also other people to what are your thoughts?
Yeah, Paul, I thought it was a valuable point to talk about kind of, most of my students are pre-med and don't necessarily need to code. But I was thinking it'd be valuable to have them do something in Excel, like a Beer's Law data analysis, and then run it through a Jupyter notebook to see the kind of the power and how you can do it in both places. But then that gives them the ability to extend if they wanted to make a notebook for some other analysis. They would at least be able to see how uh, usable it is. And they'd be more comfortable because they've already done the analysis. They're not trying to learn the analysis as well. They kind of know the general steps and what the data looks like. So I think that's the big good value to using it there.
Yeah, I would say that I've had very poor luck getting students to do things in Excel. They can plug numbers in, but if I tell them to do a correlation coefficient or something like that, they don't know how to do it. And so one of the things that I'm thinking about here is introducing this collab and running a protein assay in my freshman biology lab. And that way they will hopefully be able to visualize better and quicker what's going on with the assay so that they can identify the pipetting errors that they're doing. And then I really want to use the same thing in other classes, like the first check-in week. Repeat your protein assay. Show me you still know how to use the pipettes, that you know how to use the notebook. And so I think that that would be very valuable as a scaffolding technique. And in terms of the graph pad or whatever, I think a lot of people, especially at smaller schools like I'm at, we can't afford a subscription to that.
Thomas, another point on that, I think having the kind of linear step through of the analysis is really valuable, because if you're trying to do it in Excel, you kind of need another document on the side to say, hey, do this, do that, and they're trying to search and hit all the buttons in Excel. But in the notebooks, you can kind of walk them step by step, and could be more scaffolded that way. So I think that's a benefit too.
Yep.
The reason why I didn't join that group is like my institution subscribes to GraphPad, and GraphPad actually shows how to do some of these statistical analysis. Like it even suggests you what you need to use for the data that you have there. So it's pretty much like probably what Collab would do. So that's why I didn't join. But when Dr. Thomas Weiss is talking about how smaller institutions cannot afford it, I realized that maybe I should have joined that group so that I know what exactly the problems are.
I don't know if anyone talked about in their groups, what it's like to let students use Gemini tools in order to code. And I'll just share a brief story, which is that they love it. They think it's exciting in order to actually talk to the AI in order to generate new code. But I found out that I needed them to process data, and this would be kinetic data that's coming right off the machine. And the problem was that they didn't know what the right answer was, and so they couldn't tell if their code was working correctly. And so what I did find was I made them run through. I'd say, well, we're going to take one part of your code or one part of this data analysis, and we're going to work through it on paper and show me that you can get this value, and then show me where your code generates that value, and then we can believe the rest of it. And so I would say just there's a lot of value in working through something and hand in their notebook that they can tie to what the computer's doing, whether they're using AI to do it or not. Even if they're running through your own code, understanding what that math is, I think, an important aspect. But the code allows us to do this on a very massive scale.
I'm very interested in image analysis. If we can have a session or sometime later on image analysis, that will be very helpful, like using codes from ImageJ, like the macros, but running them on this to see how we can analyze images. That will be image processing, basically.
I have some students that are interested in developing a notebook in order to do that. So I was excited when I saw people were interested in the image analysis also.
One of my I was just going to kind of add to your point earlier, Wally, is that one of my colleagues here, for when he teaches the computing in our chemistry department in class, he has the students work as a pair to do it, but they have a designated driver and navigator. And so the navigator has to tell the driver what to do. And the driver can't do anything without the navigator. And so that helps them kind of in communicating about the coding, about why they're going to do it or what they need to do. And so then that's not so much about kind of like just clicking through the process. So depending on like to what level you want the students to understand what and why, I think it's a really great model for like, I think I'm probably gonna do it in my biochem class for a number of other things, but like having that kind of designated role will help to make sure that people aren't doing like parallel play or where they're working independently but side by side, or at least kind of how they're communicating that. So I just wanted to put that out there for people as they're thinking about how to help their students work through it, that I think that's a really great model.
I really like hearing that. That sounds really, really interesting. I'm imagining what that looks like for some of the groups that I've known, and it must be a lot of fun to watch in some cases, but also be right getting them to work as that team. Yeah, sounds really great.
How did things go in the sequence analysis session? It was curious to me that more than half the people went there.
I'll share from my perspective. I am not a sequence person, but we have a biochemistry lab where we try to do computational tools, and they're horribly out of date right now. And so I was curious about that one. And to me, the thing that I see that's useful with Python on this is you can generate such large data sets, and students don't necessarily know. I've had them before, like, show me use the blast search and tell me an enzyme that's, you know, uh, comparable to this one, and I'll get that same enzyme isoform B, and just kind of recognizing that they don't actually know what's going on and being able to process the data. I ended up choosing a terrible idea for my blast search there because I was using a cytochrome P450, and it just hit that same cytochrome P450 in 20 different species, and my number of amino acids ranged from 498 to 504, which I was just getting the same protein. So I could come up with a better protein and have them do a lot of analysis, and being able to process that big data through Python. I see that's the thing that Python can do that is going to be hard for them to do manually.
Well, I've got a question. I guess I'm going to put you on the spot here, Wally. One of the things when I do a blast search, I basically get the same exact protein back.
Yeah.
What I would like to do is a blast search that said, if it's this close, I don't want to see it. I want to see things that are less than 50% homologous, less than 30% homologous. Is it possible to set parameters to do that in a Python notebook?
Okay, yeah, and that's exactly what this notebook does. There are two ways to do that. The first way is actually that you pair the database that you're searching down, and it takes a really long time, and the files are huge. What we do instead is we search for a number, like I just picked 10,000, but we search for 10,000 sequences. So what we're doing is we're initially pulling in all this diversity. And then what we do is we use a program in there that's in the notebook called CD hit. And CD hit then clusters them according to some sequence identity. You could pick 70% or 50%. So
Okay.
in no case would two sequences be more similar than 70%. And so in this way, then you keep that diversity, but you can shrink now your data set down to something that you can look at on a multiple alignment, like 25 sequences.
That's cool. I think we need to. I mean, we've got a basal module that does blast, and we just get 1,000 copies of the same protein. And I think we need to. I'll take a look at that file, and I've got a student trying to convert all the basal files to Colab notebooks this summer.
Yeah.
And
Well,
all our modules, and this would be really cool.
this is the problem that I was trying to solve with that lab notebook, or with that notebook, was that you just can't see diversity. There's too many sequences. There's been too many sequencing projects, and everything looks the same for the first 2,000 sequences or 500 sequences. We need to search deeper to get more. Yeah.
One of the things that's really important for us is this is our first workshop, and we'll be doing more of these. And we really need to find out from you what's of value. And also things that you'd like to see that we're not thinking of. Because we got 4 people, we're thinking of the things we think of. And people who work with me know that if it's not computational, I really don't care about it, right? I got the blinders on. And which means that if there are things that are happening in the biological world of actually real living things and not just electrons, I might not be aware of it. So that would be really valuable to us. And even as we're talking and going through the session this afternoon, I'm thinking, wow, it'd be really cool to sit down at the start of August with some folks who wanted to really focus on implementing this thing in their class this fall. Or, one of these notebooks, or develop a whole new one. You want to do some AlphaFold stuff. Can you do that with a Colab notebook? Absolutely. Do I know how to do that? Absolutely not. But we could figure it out, right? And I think what I'm going to do is suggest some get-togethers, and say what group wants to do this. And there's a couple angles on this. One is to get more coding into our classrooms. Another one is to get more coding with undergraduates into the literature, because anything that we do together, if we structure it properly, we could publish it in journals like BAMBED or CBE, Life Science Education, or JChemEd. And there's not much out there right now. And I think this could be really, really valuable. So those are things I'm going to be suggesting. I'm not going to ask for show of hands today, but it's going to be on the Slack channel. And so I just want to emphasize that. But before I go into my closing remarks, fully into my closing remarks, any other comments that people would like to share? I mean, I know many of you already, and I know you're not quiet, shy people. So what things you'd like to share about what happened or what you'd like to see? I mean, we've got stuff coming in the future, but the world of coding in BMB education is changing every day. And what are things you want to see? What are ideas that you have?
It would be nice to see like how to use other fits besides linear and like Michaelis Mitten. So something far more complicated. How to navigate, like how to find those equations, right?
Right. I think that would be a great exercise. And in fact, the curve fit, you give it a function and it will fit to that function. And so you just need all you need is a continuous function. And I believe Wally, Chris, Mike, correct me if I'm wrong, but I think if you have so you could do immunoassay curves, sigmoidal curves, just all kinds of things.
Yeah, that's right. Ivy and I have my students working on. So the BCA assay is linear, up to a point or approximated by linear, but really it's best fit to a quadratic, and then solving for that. And so I do have a workbook that they've been working on that I would be happy to share. But we'll throw things like that in the Code B and B space to get out there.
That'd be great. Yeah, that'd be great. Is there any advice as to like how to handle real student data where like the data is so scattered and you're just trying to get it to fit?
That's a real question. I appreciate that, Ivy.
For protein concentration assays, this does happen. And I'm like, what did you do? And I usually just make them repeat it and explain to them. Well, we cover some basics of the pipetting again, for example. Yeah, but like at the enzymatic assays, it's more complicated.
Yeah.
If you have error bars, you can incorporate error bars into the fit, and you can weight your fit using those error bars as well. It's
Yeah,
just one little add-on into the function.
That'll be great. Yeah, because we used to have access to Kaleidograph where we could have a little bit more flexibility with data, dealing with outliers and things like that. So, okay. So there is something that you can do to.
Yeah, you just tell it, here's where the error bars are, and it'll go in there and adjust the fit and weight it based on that a couple different ways.
Oh, okay.
Hi, I would be very interested in learning about tools using the Colab environment, but to access the PDB database. So today, using the BioPython, we accessed NCBI, entry ID, and did the blast stuff. But it would be really cool to do it for the PDB, like for PDB file structure and how to retrieve useful information from the PDB files.
Yeah, we've got at least 2 of the sessions in workshop 2 are focused on PDB files. I don't know if Wally and Mike and Chris know that, but those are modules that I wrote, and so with people at the PDB. So we will definitely that will be available. That'll be part of the next round, and we don't have to wait till then. I'd be happy to meet with you and show you some of the things.
Oh, thank you. I appreciate that.
And Jose, I don't know if you with Python, you can download all kinds of other tools, right, and install them. Like you talked about doing an interesting analyses. Molprobity. I don't know if you're familiar with this software from Duke, which can do all kinds of analysis on structures. It's really a lot of crystallographers use it for like, are my angles all good in the entire thing? Are there Ramachandran outliers? So you can install and use tools in these kinds of environments. So yeah, there's all kinds of cool stuff that we can do.
Thank you. You said Molprobity, right?
Molprobity. I'll put it in the chat.
Thank you.
Right, and so you can do digital analysis, but you can also visualize structures in notebooks. There's a tool called Py3DMol, which is kind of a Python version or a Colab version of PyMol.
Cool.
Okay, well, I'm gonna roll. I want to honor everybody's time. I'm gonna roll through the last few slides on the PowerPoint, and then we'll wish you well. Let me share that screen. Come on. Okay. Are you seeing the PowerPoint now?
No, we see your presenter.
You're seeing the presenter?
Yeah.
All right. Stop sharing. And go to PowerPoint. Shrink that down. Okay. I'm going to start the presenter and then try to share the screen and see if that does it.
You can just swap display if you want.
Okay, are you seeing it now?
Yep.
Okay, great. All right, so there's an exit survey. I've actually got a link to it on the next page. And Mike, could you drop that in the chat as well? We would really appreciate if you'd fill out the survey. And there's some, pick an answer out of the list type questions. There's also some open-ended stuff. And anything we don't ask about in the open-ended questions that you want us to know, tell us. Okay, give us the more information you give us, the better we can do to improve our future workshops, to meet your needs and to build this community. Here's once again links and this PowerPoint. I'll also drop this into the chat once we're done. I'll probably leave this Zoom channel open for about 10 minutes after we're done, so you can get the links and download stuff and make sure you get the chat done. But the survey link is shown right there as well. We have a website, a GitHub channel, a Slack channel. This email, codingforbmb@gmail.com. A few of you have used that. Please use that. We're keeping an eye on that regularly, daily. Also, I didn't put it up here, but we do have a YouTube channel. So we'll share that too once we get, particularly once we get these videos refined and ready to post. So that will be available. Our next activity is going to be at the BCCE Biennial Conference on Chemical Education. It's actually on July 26th on that Sunday. And we're actually going to be running through stuff that's pretty much a reiteration of what we've done here. So if you've gone through this whole workshop, you feel comfortable with what we've worked through, we'd be happy to have you, but this would probably be quite redundant for you. On the other hand, if you went through the workshop and it was a struggle, or you step away from it for 2 months, you don't remember anything, you want a refresher, come join us. We're going to be doing a learning to code workshop in the fall. And notice what the first thing there is processing and writing files. Well, in fact, many of those files are PDB files. And I actually wrote those notebooks with the traditional PDB file format, but in fact, the PDB is now using an MMSIF format. So I'm going to have to rewrite those to reflect that. So I can do that. I'll be doing some more stuff with pandas and a lot with plotting. There's a lot of interest in plotting, clearly there's interest in sequence. So we want to emphasize that, and maybe we can put something in there with image analysis. And then in the spring of 2027, we're going to be talking about teaching with code and the principles of live coding and how it works, and what's the most effective way to do that. And it won't just be listening to us do it, you'll be practicing it with each other. And with, we'll have breakout rooms where people practice live coding with each other. So that's part of the process to help you get more comfortable. Do want to once again thank NSF for their support for these workshops, and our various institutions for their support in helping us do this work. And I want, once again, if you're interested in Slack, please email the Coding for B&B and ask to be put in Slack. We have a LinkedIn channel. We'd love to have you on there. And I'd like to see, I'd like us to build a community in Slack where we're actually trying to solve problems together and maybe even publishing papers together. If any of you are pre-tenure, one of my favorite things is to write a paper with somebody who's working toward tenure. And so I'd be really, really excited to work on that with folks and to try to build each other up. And also any notebook you create or a team of us create that gets posted on the Coding for B&B site on GitHub will have a document object identifier associated with it. You can list that as a publication. It's not peer reviewed, but actually it's peer reviewed by our community. So you could call it peer reviewed, and you can put it out there. That's probably not going to fly at MIT, but it might fly. It would fly at RIT. I think people would go for that in other places. So be thinking about that. Wally, Mike, Chris, any parting words?
I put it in the text or chat, but please join that Slack channel. That's a great place to ask questions about coding that then you got, however many people are in there that can help answer it, or to forge new collaborations or to develop new tools that we want to build. So please do that.
All right. Well, thank you very, very much for joining us. And we will get your survey data. And I'm not sure how quickly we can get the certificates turned around. I'm going to be disappearing on vacation in the middle of next week. But the recordings of all these sessions will be available if you want to go back and do them again. In fact, I'd encourage you to do that. And we'll also be putting information on the Slack channel of, here's some new things I found on YouTube. Here's a new free online textbook you can use. Here's some people you should talk to. And let's also use as a place where we can say, hey, I'm going to be at the Biophysical Society meeting in February. Who's going to be there? So we can keep conversations going.